Okay, so let's start. First, let me welcome you all to this webinar. Good morning to all. And today, I thought we will discuss something on scheme development of a building. When I say this, I'll be focusing more for entry-level engineers, where I will take you through a real project that I'm currently doing, and then explain you a few tips that will be helpful for you to start your work as a structural engineer. So if there are well-experienced structural engineers here, it might be slightly disappointing for you maybe, but there might be something for you to learn as well. I am focusing more on general tips which will be helpful for entry-level engineers. Okay, so I had made my invitation also in a similar manner where it suits or it was sent across to more of entry-level engineers. So I hope you are all doing good, and let's start. So I will share my screen and then take you through one of my current. So all of you can maybe mute your video also so that the session will be a little faster. Okay, so I hope all of you can see my screen. If not, please somebody can pick up the mic and tell me if you are not able to see it, and immediately mute back as well. So I hope you can see it. All of you can see it? Somebody pick the mic and tell me. All right.
Yes, sir.
Okay. So this is what I plan to do today. That is, I will take you through one of the project, and I will tell you some steps on project coordination, how does a project shapes up, and some tips on beam column positions, orientation of columns, some rough sizing of members, preliminary sizing of members, importance of structural configuration, having joints in buildings to suit this configuration. So these are the main points that we will try to cover. I will want to keep this a short session, say maybe 1 hour, 15 minutes, that kind. So we will quickly walk through the project. So this is one of our current project, which is a part of a hospital building in Bangalore. If you know St. Martha's Hospital, this is part of that hospital, and this is an infirmary building. In the sense, critically ill patients who are getting treated in the hospital, maybe they want to stay in the campus even after the surgery or things like that, and then recover and then go back. So it's like a residential units for patients and maybe a family of one. I mean, in the sense, since still till the patient recovers, somebody need to assist or should be with him. So it's a very small accommodation for patients. So it's like that. So one caretaker and one patient will stay in one room. So that way, it's one of the building that we are doing now in the campus, and this is the plan of the building. So if you look at the plan of the building, it may not be completely clear for you, but then what I want to explain is its shape. So it's a U-shaped, a kind of U-shaped building where you have rooms on all the sides and you have a central corridor. So that's how it is planned. That's the ground floor plan. And the first floor is almost typical. It's not 100% typical. There are changes, but it's almost typical. Most of the room area is typical, and there are other changes as well. Then you have a second floor. Again, almost typical, it's all rooms itself, but then there are slight changes. So I will show you the elevations and other complications in this building. So if you look at the sections, it's all, roof is all sloped. Now if you want to have a better understanding, I will show you 3D views of this particular building. So it's, in terms of its height and all that, it's a very straightforward, simple building. But the complication all lies in certain other nitty-gritty. So if you look at the roof, this is all sloped roof, and these sloped roofs are in RC itself. It's not steel, it's RC. This is one front elevation of the building. So as a whole, it's a simple 3-floor structure with a bit of U shape. There was some major revision after the 3D views were sent to me. So there is a slight difference in the plan and the 3D view. There is a slight difference. and there is a connecting corridor here, which is a bridge structure which connects either ends, and you have a recreational space here in the center. So that's how it is planned by the architect, and we are supposed to support them with all the structural details. If you can see here, the front columns are all twin columns. It has two purposes. One, it's a shock column, and last level, if you can see here, it is cantilevering out and getting connected to the column. So the last level is projecting out, and the column takes that load. So the sloping roof, all that is supported on the twin columns. Otherwise, the lower level is not supported on the columns, and it is all cladded up to have the required finish. So that is the requirement, and I already showed you the plans. Now basically our job starts now. Once we get the architectural plan, especially for beginners, see, architects might have indicated some column positions, but that necessarily need not be the final position. You have to look at your suitability, structural suitability. They might have indicated some columns. Some architects will indicate some columns based on their experience, so that we get a base, we get an understanding that where he is okay with the column sometimes, and sometimes they won't place any column. You have to place all the columns. In any case, it's our responsibility or our decision to decide the location of the columns, keeping in mind structural location, structural importance, structural requirement, and architectural aesthetic part and functional part and things like that. Sometimes there will be site restrictions also, which will somebody is sketching on the screen. Can you please avoid doing that, because it becomes a disturbance. So the column positions, the beam positions, everything we have to decide on this, keeping in mind structural requirement, construction ability, and architectural and client's requirements. Sometimes there will be site restrictions, all that. So now how do you start a project is what I'm going to tell you. Before doing all this, I would recommend to get a soil report, because sometimes the column numbers or the spacing of the columns and all that can be influenced by the type of the soil. So if you have a very poor soil, we might not want to have 6 meter spans and things like that. So based on that, we might have to have a different column spacing. In Bangalore conditions, rare, but if you look at other places, Kochi or any place with a very poor soil, maybe sometimes you will need, you will have very poor soil, in which case we may have to go with lower column spacing and things like that. So this decision is not just load point of view, soil type also matters. So you can insist for a soil report. Now as very young beginners, you will have a lot of challenges coming up in your way. People saying that, okay, soil report is not needed. You can go without a soil report. I would honestly request you, don't do that. Always go for a soil report, even if it's a 2-floor building, 3-floor building, whatever it is, go for a soil report. It doesn't cost much. It's only a notion that if you avoid soil testing, you can save some 20,000 rupees or 25,000 rupees or whatever. If the project is larger, the cost also will be larger. Client will think like that. Sometimes even architects will think like that. But the fact is that if your SBC that you get is more than what we assume in the absence of a soil report, the saving that you can make in size of the footing is much higher than what you think you can save. Second thing is, in case if the soil is poor than what you assume, then there is a chance that the structure gets a problem later. So to avoid that, you anyway need a soil report. So I insist soil report for all projects, and I think I don't remember if I copied that into this computer today. I'll just quickly show you a soil report. Give me a minute. I don't remember where I had saved that. Yeah. So here you have a report, bore logs are there, and the report is also given. So from the report you can identify the soil type, and there will be a recommendation generally by the soil consultant. So it tells you at what depth what is your SBC. I'm not going to go in depth into it. So soil consultant would have recommended certain things like what should be the depth of your foundation, what should be your SBC there, and any kind of, yeah, so he has recommended open foundations of type isolated based on the subsoil strata. Yeah, so I'm not going deep into this, that we can do in a different webinar sometime. So I just wanted to tell you this is important. This is important on two counts. One is, as I told you now, it can save your client some money sometimes. Sometimes it can make your building more safer by going with soil report, because what you assume may not be the right thing to do. Third thing, as a professional ethics, also considering that you are a structural engineer and not a geotechnical engineer, please leave all the scope of geotechnical to a geotechnical engineer. If you are qualified as a geotechnical engineer, if you are experienced as a geotechnical engineer, then take that work up and do the soil exploration your own. Otherwise, it's like if an architect does the structures on his own, what do you think? The same thing is what's happening to a professional in geotechnical engineering. He's losing his scope of work. So I'm not for that. So if you are a structural engineer, do the structures, leave the geotechnical to a specialist, because one thing is we need the right thing to happen at site. Second thing is that it's his scope of work. We have nothing to do with grabbing his work as our scope. It's as good as an architect or another stakeholder taking away your structural and doing himself. So what you feel when someone does that, the same thing a geotechnical engineer feels when you do that. So if you are a qualified geotechnical engineer, yes, take that as a scope. Otherwise, leave it to the specialist. As a professional ethics, I always do that. Even if it's a one-floor building, if someone asks me, can you inspect and decide your own, the SBC, I don't do that. 3 reasons. One is, I'm not a qualified geotechnical engineer, even though I can maybe make out some information by seeing it with my experience. Second thing, I want the right SBC to come in. Third thing, I want that scope of work to go to a geotechnical engineer. So if we practice this ethics, first we practice it, then we can ask others to practice it, our profession will become better. Yeah, so there are many professional problems also in our profession. So let us start from our end to make it more perfect. Now here bore logs also will be there, which will give you more clarity on the soil type and parameters. I'm not getting into that now. So once we know that, then we can know that, okay, it's isolated foundations. You have an average SBC 18 is not bad. 180 kilonewton per meter square in Bangalore is a general thing. It can go up to say 30 tons per meter square or more, based on if it's rock or medium soil. So this medium kind of a soil where you have 18 tons, 180 kilonewton per meter square is not bad for a 3-floor or 2-floor building. So you can have column spacing wider, not a big deal, not too wide, maybe 5 to 5.5, 6 meter, that's not going to be a problem. So that's how you start scheming. Then you decide your column positions. Now when you decide column positions, first thing that you need to do is keep in mind the spacing. Second thing is your functional requirement. So see, I'm not keeping this column somewhere in between the room. I'm keeping it where the walls are there. So I'm cutting a balance between the architect's requirement and my requirement. So these are all basic things. I think you will be able to understand that. Now, second thing is you will have to superimpose and see in all the levels. Say for example, if I keep one column in this particular location here, what will happen to the other levels? You should have a thorough understanding. So you have to superimpose. So this is where tools like Revit comes handy. Here in AutoCAD, you have to copy and place the columns in one level and then copy it to other level and see where it comes. So if it's a typical level, then you will not have a problem. You can easily place your column faster. Otherwise, you will have to move around and adjust and do that. So superimposing and seeing is a very important thing. So as a beginner, you should be able to visualize, swap over columns and floors and understand the difference in plan and visualize that a column placed in one plan, how it will be in the other plan, will it be coming inside the room. So that visualizing ability you should have. or you can use tools like Revit for your GA production and your 3D modeling, wherein you will be able to get a very good in-depth understanding on your scheme. So you do either of this, but as a beginner you can start seeing drawings and going to sight and understanding, because all this will improve your visualizing ability. So visualizing ability is a very important skill. Even though you are a master in structures and you can decide if a structure is coming into torsion or not, you can decide the shear wall position, everything you know. But then if you are very bad in visualizing things, your architect and client may not be convincing, because they are looking at things that they can see. They don't know how you are analyzing. They don't know you are using ETABS. They don't know you are using FEM. Yeah, they don't know about that. They know about what is visible to them. So they know about spaces. They know about discussing about a stair clashing with a beam and things like that. So if you are not able to appreciate in their wavelength, then there are every chances that you will be underrated. So please develop your visualizing skills, and that can be done by studying drawings, modeling, and by visiting sites and seeing really executed, completed building. And during construction also, if you visit, you will be able to idealize things better, visualize things better. So now coming to the plan, it's all straightforward. You have rooms on all the sites and a courtyard. Now for the courtyard or for the recreation space, there is a slight complication again. I will open one more drawing. So while that's opening up, I will show you the ETABS model that I have done for that. So here is the plan of the ETABS model. So this is your ETABS model. All the slope has been achieved. It's a little difficult to model the slopes until and unless you use a tool like Revit, but I have modeled this without Revit. So I have extensively used extrusion and extending command to develop this. So if you look at this, it's perfectly aligning everywhere. I have not done any kind of adjustments in the model. It's all perfectly modeled to match the architectural. So if you want to see only that part, yeah, is it for everyone? Even now? Hello?
Visible, sir.
Visible, sir.
It's okay. It's okay. Fine.
Because I have shared it. Who has the problem? Maybe it's stuck or something for you? Is that the problem, or nothing is visible?
Yes, sir. Sir, I'm not able to see anything. Shall I leave and join once again, sir?
Maybe do that. I'm not sure, because others are saying they are able to, or maybe you are not sure. It's something at your end. Maybe you can leave and rejoin. Who is this? Oh, okay. Yeah, you can leave and rejoin and try, I think. Okay, I will select the roof area alone and then just show you. These are all shells, shell thin and then meshed to achieve accuracy. So that's how I have done that. Now, once you model up, okay, before that you will have to decide your column position. So as I said, keeping in mind it's a demanding structure where you might need some long spans. So I will show you the recreation area now. Recreation area as in, there is a common area where a recreation space is provided, a kind of room. So here the challenge is there are level differences. So I'll just try to explain you. So here there is a connecting bridge between the blocks, or between the recreation space and this corridor. Here there is a corridor. So that corridor is coming here at two different levels. So that's what you can see here in the section. You can see a few steps, and from the slab you have to step up and then get into the top of the recreation space. So here there is a RC seating arranged, and here there is a tree that you need to plant. So they say it's a lightweight tree, but we never know what will happen there. So it's all going to be filled up with soil, and you have a tree on top of the roof. So that's what I need to achieve structurally, and they were not allowing me to have a beam down. Yeah, so this is the section of the room, and they wanted a kind of flat plate without beam projecting. There shouldn't be any beam downwards. So I asked them, why you are not allowing me a beam there? Why you want a flat plate? I can give you, but then your thickness will be too huge. Then finally, I proposed a kind of grid slab where on equal spacing I gave beams, so that was acceptable to them. So this is the section. So you can see a beam, a beam, a beam. So when you imagine it, when you are inside the room and looking up, you see a kind of grid. So that was better for them than having a single or two beams here. So at regular intervals, I give many beams and achieve the structural requirement. So you have to think in a slightly different way when such a requirement exists and try to solve the problem. So this is how I did that, by providing a grid floor. I will also show you a typical floor plan. So this is a typical floor plan for that particular, this is a structural plan for that particular building, first floor level floor plan. So they have already done up to the first level, and the upper levels are being, first floor is not cast yet, they are reaching there, and maybe this month sometime it will be concreted. So this is the first level structural plan. Now our job includes deciding the depth, deciding the location of the beam, deciding the location of the thickness of the slab, things like that. So now let us quickly discuss some good tips. I am not going to base this project for deciding the column position because it takes a lot of time and it may not be clear on your screen when I explain certain things. Now with respect to column position, where do you decide the position of the columns? There is no hard and fast rule, but for such a structure you can expect your spacing of the column to be say 6 to 7 meters, not more, and not less than say 4.5 to 3 meters, because sometimes it becomes uneconomic if you give columns too close as well. But many times you might have heard clients and architects saying that reduce the number of columns, it will be more economic. It's not like that. If you reduce the number of columns, there is no guarantee that your structure is going to be economic. Many times it will become uneconomic because your footing size increases. If you are designing for seismic, your seismic demand has to be met by less number of columns. So maybe you need a larger shear wall, or sometimes your column size will shoot up. So it's not right to say that less number of columns are going to be more economic. It's not true. But if you place columns at say 3 meter intervals everywhere and then get say minimum steel of 0.8% for all columns, then yes, you are wasting money, because simply for the reason you are giving a minimum steel, simply for that you are having more number of footings and things like that. But as long as your column is say have 2 to 3% of steel and you have taken care looking at the efficiency, then there is no point in saying that less number of columns are going to be better. Nothing like that. Yeah, so structurally your cost is not going to increase simply because the number of columns are more. If you need that many number of columns, that is the right number and that will be the right economy. Yeah, so I would say don't reduce the spacing to something like 2 meter, 1.5 meter, like that. It should be it will come to you with experience, but as a rough rule I'm telling you, not more than say 6 to 7 meters and not too less. Now if you ask me, can it not be 8 meters, there is no hard and fast rule, as I said. If your span is 8 meter, then your beam dimension also will have to be slightly more based on that, based on the requirement. Your column moments also might be more. So if there is a situation in one place that you need 8 meters and you have no other solution, then yes, you go for 8 meter. It's not a hard and fast rule, as I said. So that's all about columns position I am telling now. I can, if somebody is really interested, I can give you one plan and you can do that and then come back to me and I will help you out with your spacings or the positions. It's something that you need to gain with experience by doing projects. Some of you might already have that experience. Some of you may be at a start. I don't know, because it's a mix of people here. We have many people and some are beginners and most are beginners as per my invites. Now looking at the orientation, I want to give you some tips, very quick tips. So here you can see that I have oriented the column towards grid 2, along grid 2, not towards grid A. The reason is simple. Gravity load point of view, your inertia is BD cubed by 12 is more along your depth because BD cubed by 12. So D is your larger dimension. So in this case, the larger dimension is oriented towards the larger span. So this span along this A to B is 6 meters and 1 to 3 is 4 meters. So gravity load point of view, I clearly know you can also understand that your moment will be more from this frame than this frame. So I have oriented it in this direction. I hope that's clear. Now, if this span was 7 meters, I might have tried, or I might have in my first analysis kept the column in the other direction. So that's a simple rule that you can follow. Now, this is for gravity loads, for dead load, live load. Tomorrow, after analysis, maybe your seismic is governing and your other, say you place the column like this, since the span is more. Now, after analysis, this is called M22 in ETABS and MY in your SP16 or textbooks. This is called MX, or which is the major axis. So if your orientation is correct, your MX should be more than MY, because that's what ideally we are looking for, because you have more capacity or more inertia in that direction. So if your MX is more than MY, your orientation is probably right for the optimum steel. But every time that may not be possible to do that, because say for example architect wants it in this way because there is a door here, yeah. But then if your MX is 100 and MY is 90, then there is no much change. There is no much difference in your steel after rotating as well. So you can go with anything. Maybe you have 2% of steel, after rotating you may get 2.1% of steel. Sometimes it may be 2 and you may get 3, but then if architect insists or if the client insists that he prefers the other orientation, you can orient that. It's not a big deal, but this is the right way of doing it. So first you place your column keeping in mind your gravity conditions, which you can appreciate very quick, and then do your analysis. Then check for seismic. If seismic is giving you a different moment, more than gravity of course, but if your My is more than Mx, you can slightly check by rotating and check it, and then if your steel is drastically reducing, you get to know that. I mean, these are easy way. There are with experience I can appreciate it with other ways, but as a beginner this is an easy way for you to check. So orient your column for gravity, then do your earthquake analysis. After everything you see which moment is coming, or the governing case moments you go and check. If Mx is more than My, fine, your orientation is okay. If My is more than Mx, then probably you can rotate and see. And when you rotate, if there is a drastic reduction in your steel in the column, change the rotation. That can be a quick rule for checking out the orientation of the column. I hope you understood that. Then coming to sizing, I don't want to give you any rule. There are many rules. If you even Google, you will get PU by FCK BD. You keep around 0.6 max and then size your column with a MU by FCK BD square of around 0.05. That should be fine. But then I would suggest you iterate it. You can easily do that with ETABS. You give a start point with your experience. Say if these kind of buildings, you can go with say 230 by, if it's in zone 2, say maybe 230 by 500 or 600 size for the column. 450 you can try, and then after your first analysis you can keep on doing changes. You can increase and find out the optimum size. It's easy to do that. There are many other rules, we will discuss that in some other time, but this is an easy rule. Now coming to beam position. Generally there are 3 reasons for having a beam. One is to split the slab size. Say for example, I will draw and show you. Say if you have a room like this and say you have a column, assume that this is 6 by 5 or say 7 by 6. If this is the size of the room, naturally you know that your span is 6 meter for the slab. Now, if you go by deflection rule of slab, which I think you know, L by D ratios. Now, if you go by that, this is a single span slab, so this is discontinuous slab, so that comes to around 20. So if you look at the depth of your slab, it's going to be very huge. It may be more than 175 to 200 mils or even more than that. So you should be knowing by your experience now, even BE or MTech experience should be fine enough to know that for a normal building, it is not great to have any thickness of slab more than 125 to 150. Yeah. So having a very thick slab for such a small room is not a great thing. So you ideally would not want to have a thickness of slab more than 150. Now with 6 meter span that is not possible, so you will give a beam. Now the question is, will you give the beam in this direction or in this direction or both? Now I would obviously go with the shorter span. 6 meter is less than 7 meter. So if everything else is okay, if architecture is okay, if client is okay, then I would give the beam in 6 meter direction. Yeah, so this converted my beam, my slab into two smaller slabs of 3.5 meter. Now this 3.5 meter slab is a continuous slab as well, and I don't think I will need anything more than 120 mils or 100 millimeter also may be fine, maybe 125 or 120 based on your practice. I mean, I'm okay if good quality control can be achieved, even 100 millimeters slab thickness is possible. But if you have electrical things, wires and all that running through the slab, maybe you go with 120 minimum. So it all depends on these kind of things. So you can 3.5 meter deflection point of view, you will not need, strength point of view, you will not need more than 100 or 120. Yeah, so that way you can decide. So one reason for having the beam is split slab into manageable thickness. Yeah, so that's one reason for having a beam. Now second reason for having a beam is tying a column. So for example, say you have columns like this, and even if this is 4 meter by 3 meter, I might prefer to tie this column. That's to reduce the slenderness and to reduce the sway of the column. At least I will give a concealed beam there. I am not going in depth into that, but that is another need for having a column. That is to tie, having a beam, that's to tie the column. So every level, your columns preferably should be tied by a beam, if not by a slab which has a continuous steel over it, which is like a concealed beam. Now let us not get deep into that now. Let me just tell you the need of a beam. So the second requirement of a beam is to tie the columns. You cannot leave the columns untied for 20 floors. It will be really slender and it will be swaying. Now basically what this tie is doing is, it's giving a tie action. So when the column sways in one particular direction, it acts as a compression or tension member and pushes or pulls it back. So here, if the sway is in this direction, it's being pushed or being laterally restrained by that beam as a tie. Also, it helps you to transfer the load throughout. So that's all the tie action. That's all what I mean by the tie action. Same way, if it is swaying in this column, this is being pulled by that beam. So these are behaviors that we want in the building. So we will have to tie all the columns by a beam. So that's the second requirement. So in case if the client has an objection in having a beam here and ask you to avoid that, maybe you can give a concealed beam here, a wide concealed beam here with top and bottom steel running through the beam or the slab. Now one point I want to add here is, if you are considering this as a concealed beam, don't design this slab as two separate slabs. That's a big problem. You have to still design it as a single slab. If this is a small, slender, concealed beam, even though you call it a beam, it's not a beam. You have to still design the slab as a single slab. Otherwise, you will have cracking. Yeah. Though you call it a beam, it's not a beam. It's a tie only. It's just tying to reduce the slenderness of this column. So you cannot take this as a beam and then say S1 is supported on that beam, S2 is also supported on that beam. No, it's not like that. S1 is a single slab like this. Those who have confusion on that can model such a structure and give a slender beam here and then model a shell here and analyze and see how the slab is behaving. It will not hog here. It will not hog here because this beam, which is a concealed beam, is going to bend along with the slab. So you can model a small structure, model everything as a shell thin, put the load, give a concealed beam and check your behavior. You will be able to appreciate that. Very rarely it will hog here because this beam is not stiff enough to support the slab, so it's going to deflect along with the slab. It's a part of the slab actually. Only thing is that you have some reinforcement running through and through to connect or to tie the column. So you can model and check that. So that's about the two requirement of the beams. The third requirement is generally when you have walls on top of your slab. Say for example, you have a room like this. Say it is 3 meter by 3 meter only, or say 4 meter by 3 meter, or say 5 meter by 3 meter. But you have a wall somewhere, say a 200 or 230 thick wall here. Ideally, I would like to see if I can give a beam here so that that concentrated line load of the wall is taken by the beam and then transferred onto the other. Yeah, but it's not 100% needed. Sometimes you may be able to put the load onto the slab. Only thing is that again you may have to give a concealed beam here to distribute the load, or you may have to have higher thickness for the slab, things like that. But if possible, and if the spacing is not too close, I would definitely go for an additional beam if there is no other concern like architectural point of view or constructability point of view. Yeah, so basically 3 rules. 1, to split the slab into manageable thicknesses. 2, to tie the columns. And 3, to support walls wherever you have walls on top. Now when you do this, you have to think one important stuff. You have to be good in visualizing again. See, this, assume that this is the first level of a building, which means it's ground floor roof. Now in ground floor your wall location may be here, and in first floor your wall location is here. Now in most of the cases, architects and client will not be okay to have a beam here because it is ground floor wall is here, which means he is expecting or they are wanting the beam to be here so that the beam is not visible in the room. Yeah, so in such cases you may not be able to give a beam there to take the weight of the upper level wall. Then you may have to rest it on the slab. So you have to take decisions based on your requirement and everyone's requirement. So it should not be that you overdo things and make the client really suffer because of that. If there are reasons that you cannot avoid that beam, you cannot and you should not. But if there are possibilities, you should explore that. So that is what you need to see. So when you scheme a building, from your perspective, you need a beam where you have a wall on top of your slab. And keep in mind that client and architect, and even if it's your house, you will be okay if the beam align with the lower level wall, so that the beam is tucked inside the wall. So cut a balance between that. So if you have a typical floor, you have no issues because all the walls are in one line. You can give beams everywhere you want. But mostly in houses, in residentials, you will have the problem where you have different functional requirement at first and ground and first level. So there will be some mismatches of the walls, especially when the architects are crazier. You will have more difficulties. So it all depends on client, architect, your everything. Yeah, so it all depends on the requirement. Now again, sizing of the beam, I would recommend you go by, there are many thumb rules, but you can have a feel for it by experience, or you can do a trial and error to start with. You observe how much is coming and it will come to you by default. I mean, in the sense, if you do 3-4 projects, you will have that feel for the structure and you will be able to appreciate. Thumb rules are many, but I don't want to give you something now because it needs to be used judiciously, otherwise it may work in some cases. You will come back and tell me, hey, this size is not working, so I don't want that. So you do a iteration and find out. It's not a big deal in ETABS. You model, see the forces, see the steel, then you can always increase or decrease as required. It doesn't take much time. So that is something. Now, in case if you want to size the slabs, now sizing the slab, thickness of the slab, deciding that is a bit important, even if you are a beginner, simply because the loads of your slab is going to be huge. Even though slab is structurally much more less challenge than beams and columns for you as a beginner, slabs are going to put a huge load if your thickness is not right. So I would suggest you always get the thickness of the slab right in your scheme. If you use 200 thickness instead of 100, your entire thing can go crazy. So I would always recommend you fine tune and finalize your slab thickness first. And if you want, you can go by the deflection rule, because 95% of the cases in slabs, moderate spanning slabs, deflection is going to govern. And if you, what I mean is the thickness decision. So if you decide your thickness based on deflections, that could be, or that would be the final thickness of your slab as well. And in case if your slabs are 3.5 meter, 4 meter, then 100 to 120 will always work as well. So you can use your L/D rules for finalizing your slab thickness. Now L/D rule is not very straightforward as you think. I would suggest you go through my free course. Here there is a free course called Structural Basics. Some of you might have gone through it, some of you might not have gone through it. So in this particular course I have given, if I remember, the L/D ratios and how you need to decide. I am not exactly remembering if that particular topic is covered, but there are many things on structural scheming here. Durability aspects, strength aspects, stability aspects, all these are covered. I think even the slab sizing is covered in this particular course. You can have a look and then if it's available in there. I think it's available in that. Now another thing I want to stress when I speak about scheming is, even this particular building which I have done, I'll better take the tabs. See, ideally if it was a very large structure, I would have split this building with joints and made it more uniform. Now this is a U-shaped building, but this bridge helped me to reduce some kind of torsional effects in this particular building. And it's a low-rise building, so I am not really bothered about dynamic analysis, and it's in zone 2. Otherwise what would have happened is, this building would have had first mode of torsion here, because it's a irregular shaped U-shaped building. Now to make it a bit clear, those who are new to this, see, a rectangular building is very the demand for seismic is very less in this particular building if the configuration is rectangular. Now to understand what I'm saying, you need to know what is earthquake. Now earthquake, many think that, especially since here more of you are freshers, I'm just emphasizing on this. See, earthquake is not something is coming and hitting your building. Now if you talk about wind, I'm going to draw the elevation of a structure, say this is a frame. Now if wind is coming and hitting your building, it's a direct force coming and hitting your building. The wind is blowing outside, it comes and hits your building and your building deflects. But that's not what happens in the case of a earthquake. It's not that some wave is coming and hitting your building. Many have that wrong notion. It's not that way. It's not that a wave is coming and hitting your building. No. Earthquake is not a direct force, but it's a displacement type of a load. Now how does it comes? Now this is your building, and here you have your ground, and your ground is moving. Now that ground movement or the ground acceleration is what is creating the displacement in your building. And I always tell, or I always compare it with a normal moving bus. Now if you have a bus, some of you might be my own students, so you might have learned this in the course, others for the benefit of others. So if you are traveling in a bus, and if you are standing somewhere and if you are not holding anywhere, and when the bus takes off all of a sudden, what happens? You will feel inertia. So the exact inertia is what is earthquake, nothing else. So based on your weight, so if you are two people traveling, one with a larger body mass and one with a lesser weight, the 100 kg fellow is going to have more problem because the mass is more and the lateral force or the lateral inertia created due to your own weight is going to trouble you more. Same way, when you have a building and when the ground moves, the building experiences inertia. So the taller the building, you have the CG higher and higher, and more the mass, you have more inertia. So if you have two same buildings of same height in the same region experiencing the same earthquake force, then the one with lesser weight is going to have lesser seismic demand, because the larger one or the heavier mass one will have to take care of its heavier mass. So as a structural engineer, it is always advisable to reduce the weight. So encourage others to use less weight things. So if you don't really want a 230 thick wall, go with 100 thick wall. If you really don't want 150 thick slab, don't give it. So many times you think that more size is always good. Not in the case of slab. If you have 150 thickness of slab instead of 100, you are simply punishing your building by increasing the seismic demand, because more the inertia, more the lateral force. More the lateral force, you will have to make your building more stronger. Yeah. So right assessment of load is very important for right behavior, right design, right detail, right experience. So don't think that giving more is always good. In case of columns, maybe sometimes it may be good, but not for all members. If your slab thickness is increased to 150 instead of 100, you are bringing in more seismic demand for the building. You need to satisfy more inertial force, which means your columns are going to be over reinforced than needed. So right estimation of loads are really important. So always coordinate with your architect. If there are certain uncertain things like the thickness of your tiles, thickness of your stair tiles, if they have not been able to freeze that, try the best to freeze that, because all these are going to help you to fine tune and reduce your seismic weight and thereby economize your structure. So simply compromising is not the solution for reducing the structural cost. You can stick to all the codal provisions and still achieve economy by adopting good practices like this. So if an architect is not able to freeze certain things for you, try what best information you can get from him and try to fine tune it to the best level possible. If you don't do that attempt and always think, okay, let me go conservative, that's when you have the problem and you end up compromising certain other thing. You don't know. Finally, if your load estimation is wrong, you will never have a control on what you have done, because tomorrow if somebody comes with a change, you never know if you have taken the right load. If you have taken the right load, you always know that there is scope or there is no scope for adding something else. So always have a control on your design. That is possible if you have estimated the loads 100% correct. Now if you want some kind of margin for your design, you apply that margin when your detailer gives you a print, and then when you check it, you increase your steel. Then you know, instead of 212, yes, I have given 216. So that margin, you have a control on that. But if you have overestimated everything, okay, load, take more. What happens is, you round off it many times. Say, moment is 43. You rounded it off to 50. One round off. Load you had already increased. Now moment you have rounded off. Now steel you got say 426 as the, or 440 you got the steel required. AST required 440. Now 216 is only 400. Okay, then let me give 220. Yeah. So if you had taken the right load and the right moment here, maybe this 440 would have been 392, then 216 would have satisfied. So you are missing that point by simply increasing the load and simply rounding off the moment and all that. So don't do that. Always estimate right, correct figures. If you want to apply your factor or apply your, I'm not talking about the factor of safety. That's always going to be there. Yeah. So what I mean is, if you want that increase or if you want that cushion, always apply in the end, and that end is the detail. Yeah, so if you have given 212, if you want to make it 216, take that decision at the last, not all through the process. That is duplication of safety. Yeah, you have a margin in loads, you have margin in moments, you have margin in steel, you again come back and then increase the steel finally. Now, as a beginner, you should be even more cautious about this, because maybe multiple people are doing this. You only estimate the load. Yeah, your senior checks the moment. Finally, your main boss decides the final steel. So he may not even know what the load you have taken. So be very judicious. Be very careful when you are estimating load. Communicate with your seniors. Communicate with your other stakeholders. This is what I have taken. Sometimes somebody might come up saying that this is a reading room and it might end up as a library. The loads are different. Sometimes somebody might come to you saying that this is a library and it will end up as a reading room. So the load requirement for a reading room and a library is very different. And when somebody says it's a library, you should have the the presence of mind to ask them what library, because many times it may be in the memory of a person, say Jawaharlal Nehru or Patel or whoever. So sometimes they will keep a statue of the person in whose memory it is being built. So you may have to consider that as a load. Sometimes this is not communicated. So estimating the loads, understanding the requirement, all these are very important in deciding your scheme. So sometimes you will think that you don't need some beams, but when you have a overloading or higher, heavier loaded things like that, you might need more things in your scheme. So these are the things I wanted to tell you. Now coming back to the configuration, I started off with configuration and deviated to something else. So now when you have seismic, when you understand the seismic behavior, now you should understand. Now if you are standing in a bus in an awkward position, yeah, with your hands, see, if you are in a bus, see, you can, if you have seen buses, this is how the Bangalore buses looks like. You will have a suspender here. You can hold on this, or you can hold on the main bar. Yeah. So if you are holding on this suspender, you are not really stable. But if you are holding on the main bar and or maybe the vertical bar, if you are holding on that, you are more stable. So your building is also like that. So if you are holding on to this, what happens? You are in an awkward position. When the bus breaks or when it takes off, the chances that you are going to fall is more, or you are going to sprain your joints. Yeah. So the same thing happens if your building configuration is not great. So if you have, say, an L-shaped building, what happens is, if your ground is moving in this direction, if somebody is doing something with the screen, please stop doing that. So if you have a ground movement in this manner, see, this is what happens when somebody takes control of the screen. Then I lose it and the color of the screen becomes dull. I cannot control it now. Now, when the ground moves, what happens is, if the building is having a leg like this, L-shaped building, then there is a good chance that this rotates when the ground moves. Whereas when you have a uniform shape, you will have a linear movement for the building, which is easier to control or which will absorb the deformations. Now when you have a torsion in your building, that is brittle, and there are chances that your building fails much faster. So what you have to do is, you can introduce a joint here, yeah, and make this two separate buildings. So this is building 1 for you, this is building 2 for you. Analyze it separately, treat it as two different buildings, yeah, and you also have to decide the gap properly, so that in the event of earthquake, both the buildings are not going to pound each other. So there are rules for that, which we will see later, not in this session. But separating this building into two, this is part of your scheme. So if you have a U-shaped building, it may be even 3 number of buildings structurally. Functionally, it will be a single building with a small gap between that, and people can of course move between this, but structurally you are making it independent. Yeah. So this moves very properly. You will have a linear translational motion as your first mode, yeah, for both the buildings. So it is regular. So when you have a irregular building, the problem is you have a column here and say you have a column here, there is no direct interaction path between that. So it interacts in a concave shape, which means your building is going to rotate. That's why the torsion is getting generated. All your slabs are interconnected, so it is all stiff. So the interaction is like this. Yeah, so any concave shaped building like L shape, plus shape, all these are not so great. Seismic point of view, seismic behavior point of view. So that's why you better separate that into multiple buildings with joints. Now there are many other reasons for having joints. Expansion joint is a reason for expansion. Contraction requirement is a requirement for having joints, but that's for a different purpose. Here I'm talking about configuration purpose. Same way, when you have even a single building, say a single building, but one side, this side is 10 floors and this side is 2 floors, even then I would ideally want to separate this into two different buildings. Here the reason is, again, making it regular. When you have different mass at two different locations, it's not great, and vertically also it is irregular. So 10 floor I will deal as a single building, 2 floor I will deal as a separate building. So that is another aspect. It's not that you cannot do it. If there is a real requirement that you cannot separate that, you may have to, but then your demand, seismic demand, is going to be larger. When I say seismic demand, you will need to spend more money to achieve seismic resistance, is what I mean. Yeah, you cannot compromise in any ways. So you have to design for this irregularity that will take more money from your client, or if it's your building, it from you. So that is the significance of configuration. You need to decide the configuration based on the shape of the, so all this works really well when you are on board, when architect starts the planning process. Many times that doesn't happen. You get a completed building, in the sense a scheme is already frozen between the architect and the client, and you enter the scene only after that. So that's where all the problem starts. If you are engaged, if you are there in the project in the early stages, you can always give your inputs and make the building really structurally performing one. But many times in India that doesn't happen. That's a different thing altogether, which we will discuss in some other discussions. But if you are able to give your inputs, give that well early in the project, so that we get a performing building. Yeah, so I think that's all I wanted to discuss. I took you through one project, then coordination, as in, yeah, so all these things, if you are early in the project, you will be able to communicate with the client and the architect on your requirement on the orientation and things like that. Again, load calculations, as I said, is very important. So if you don't have an understanding on the loading, if something is not being finalized by the architect, you say that this is very much important for you. Yeah, so many times what I do is, sometimes if the architect is hesitant to give me the load, or he says, okay, I don't know the wall positions, it may keep on changing. In such cases, I make a load diagram. Yeah, or sometimes it's an office building and he says that, okay, I might have partition wall everywhere. Then I will sketch on my own and then say, this is the intensity of wall that I have taken. You can have this anywhere in the floor, but not more than this length. So I will give a total length for him and the thickness for him. You cannot exceed this in this particular space. If you exceed, my design will change. Yeah, so I will consider a flat 1 kilonewton per meter square or whatever, and then say this is the best possible. Now tomorrow don't come and say I need a 230 wall on this room. So that prompts him to think more, and maybe, see, the basic problem is that nobody wants to spend time to give you information. So that's the problem. So if you probe like that, if you make them think by making him responsible, yeah, then there will be faster decisions. That's what my experience tell me. So that's a simple tip for even an experienced engineer. I prompt other stakeholders for giving me the information by doing this. So I give a loading diagram. Yeah, so if he has given me a plan, yeah, so if this plan is available, if the tree weight is, okay, I don't know, man, I don't know the weight of the tree, it may be something. Yeah, and he has written lightweight. So I prompt them by saying that, okay, in this area, I have considered a fill of 750 only, tomorrow you cannot come by saying it is 900 or 1000. And this tree weight, I have considered this particular species. So if you Google search, you will get the weight of that tree. You say this is the weight I have taken, and it has to be exactly on top of this beam. This particular project, the architect has now confirmed to me that this tree is going to be planted as a sapling. Now, if this is a sapling, there is a kind of load. If it is a tree, there is a kind of load, because I need to think about transportation. Say, for example, he may lift the tree from here and place it here before putting it here. Yeah. So if this is a big tree which is being brought and kept here, then I need to design the entire slab for that weight. But if it's a sapling he is planting here, then the chance of that being moved is very rare. It's not going to be moved. Yeah. So I don't need to take that weight in the corridor at least. Yeah. If it's a big tree being brought, then maybe even in the corridor, everywhere I will have to consider some kind of cushion. So all that is important. So to make them confirm all this, send a loading diagram. It may be a little more time for you, but it's worth spending that because you get more refined information. It's going to help you, it's going to help the client. Finally, it's going to be more economic. It's going to be what is needed. But make it sure that you get a good fee for doing all this. So work only for projects which get paid. Yeah, so that's another thing which we will discuss some other time. So there are various things involved in this, but finally what you need to do is you need to do things 100% correct. Yeah, and if certain things are not letting you do that, don't take such projects. So that's all I can tell you. So as a beginner, I want all of you to be 100% ethical, 100% accurate, 100% abiding to the code. Saying that, okay, 3-floor building doesn't need earthquake analysis is not a right thing to do. There are other ways to economize. If that's not within that, that's it. That's a minimum requirement. Don't say that I will do only for gravity load and then say I will make it economic. That kind of economy we should not give. And we only have encouraged others to ask for it by giving that. Yeah. So let's stop doing all that compromises. But we can always fine tune. We can always look for more information. We can always look for fine tuning the load. We can always look in engaging and coordinating and making it better. Yeah. But not on compromising on what is needed. So with that, I will end my talking. So if you have something to discuss, please feel free to ask me. Anybody?
Can you?
What is that you wanted?
Already you told that the 10 floor, 2 floor.
Yeah. See, there are various reasons that you need to have. You may need to have joints. Yeah. So I am concentrating only on irregularity point of view. So there are different kinds of irregularity that you can have in a building. One is your horizontal irregularity, which I spoke now. When you have a L-shaped or a U-shaped building, then you will have torsion in your building if you don't attend to it. So to avoid torsion coming in your building, I suggested you split that with a joint in between that, so that it's a 2 uniform or rectangular shaped building. Now second point I mentioned there was when the mass is different, or when the vertically it is irregular. Say for example, one side is 10 floor and one side is 2 floor, then again it is irregular vertically. Yeah, so even that will have a performing problem. So it can become too regular building when it is split into 2. Yeah. So these are structural requirement for breaking or for splitting the building. You also can have expansion reason for having a building. Say you have a 100 meter or 200 meter long building. It's all 2 floors only. Yeah. Everywhere it is uniformly loaded. Even then you will need a joint sometimes, because as per code 45 meters is what code allows you. More than that you have to have an expansion joint. You can do temperature load analysis and do away with that joint, but I am not getting into that. There are possibilities in ETABS. You can do temperature load analysis, and if the increase in stress is taken care by reinforcement, you may not need joints for expansion reasons. But the joint that I mentioned today is about joints that is needed to make your building regular. Irregular building into. Did that clarify? Yeah. Sharavanan is the.
Sir, I just want mean beam. So
Hmm.
we have option that using conceal beam or hidden beam, we can tie that. But how much is effective when the building is G+4 building or any multi-story building? I mean, and we don't tie that two column in one direction. In one other direction it is tied, but in one direction throughout the 4 floors it hasn't tied. So how much is effective that hidden beam
No,
in tying the
no. What is stopping you in it is really effective, and what is stopping you in providing that? Because anyway, you have a slab there, so conceal beam is nothing but a slab. Only difference is that you are running some top and bottom reinforcement through and through. In slabs, generally your slab rebars are not through and through. Your top bars especially is cut, and your bottom bar is also cut. Your top bars are only near the supports. So only thing that I am asking you to do is to run your top reinforcement through. Bottom reinforcement anyway you have more length, only that towards the end it is cut. So only you are losing couple of bars, and by tying it you are getting a better performance. So there is nothing that you should be worried about in providing that. In 2 floor, even in 1 floor, you have to tie the columns wherever possible. Only if it is a cutout and if it's a double height column you will have an issue. Otherwise, everywhere you can tie, you have the possibility to tie. I don't see a reason that you should not be tying it. It's a matter of 2 or 3 rebars. And the performance difference that you will get will be much different. You will get a much better performing building in cases of seismic events and in cases of accidents. Any other question? Anybody? Somebody else was trying to ask a question. Anyone has a question? Now, in case if anyone wants, yeah, any question?
I had a doubt.
MSRID Tushar. Okay.
MSRID Tushar. Yes, at hospital building. I had a doubt regarding the column position. Why didn't you put that bathroom, sir? Like, so just a doubt raised. So if you can open that plan, I would be yes, sir. In 3A column, sir.
This one.
Yes, sir. Besides that, 3A.
This one.
Yes, sir.
Yeah, this is obvious because see, this is an internal column. Now 4 and 4 is your dimensions, and here you have 6 meter. Yeah. So if I draw the frame, this is 4. If I draw the bending moment diagram, I am again talking about gravity only. Okay. If I draw the bending moment diagram of the beam, if this moment is x, this moment is also going to be x.
Yes, sir.
Now here I have my column. Now you think about redistributing that moment, how much is going to come onto this column, because that's a, what do you call, it's not having any moment from the beam. Yeah, because you have same moment across the beam, which means that nothing is redistributed to the column. So it is, for gravity load point of view, it is a uniaxially bending column. Yeah, so that's the reason I have put it in the other direction. I mean, once I did the earthquake analysis, there might have been many other things changing and deciding that, but gravity load point of view itself, what I have done there is what will be needed. No, bathroom as in you are talking about the load variation.
Yeah, yes, sir, yes, sir.
But that's a very less load variation. Here the thickness of the fill is around 300 mils, and it's cinder that you are going to put, and even though there is a point load here coming from this, that load variation is not going to be as much as the 6 meter spanning variation. So here you have 6 meter, on the A to B distance is 6 meters, and you also have a point load coming here. Yeah, so that is only going to be determinant. Yeah, so the span difference is almost 0, but due to the load variation, there will be some moment towards the toilet side, yes, but that is not going to be more than what is generated by the 6 meter. Yeah, because the 6 meter versus 0 meter, there is nothing here, it's the end column. So your inertial requirement is more in this, even in gravity point.
Yes. Thank you.
Anyone? So in case if there is, as I said here, it's a mix of people. There are some my students already who are my students. some are working professionals, and some are very new. Now there are a few free courses that we are offering for beginners benefit. So this is one such a course. Then this civil engineering quiz will let you know where you stand in terms of the current requirements. So there are a lot of questions that will be needed if you are trying to practice or if you are trying to get into structure. So if you are able to answer most of it, then you are almost there. If not, then you have a lot of learning needed. So now, in case if anyone is looking to learn on a systematic basis guided by me, there are a few courses that we offer, and this is one such course. So this course is a comprehensive course where I'm going to teach you about scheming onwards to design, detailing, earthquake analysis, everything in this course. Yeah, so it will be a beam and slab system structure. You are going to learn about the role of a structural engineer. You are going to learn about the scheming of a building. Whatever we discussed, you are going to learn in a very comprehensive manner. You are going to learn ETABS. You are going to learn every aspects of ETABS with respect to RC buildings, and how do you compute loads, every load like dead load, line load, seismic, wind load, everything, all the load combinations, what are the different kinds of combinations. If you have an irregular building, what are the different separate load combinations that you have to consider, wind load combinations, wind load basics, earthquake basics, everything is going to be covered, and some very advanced topics like stiffness modification. Then what is the difference between yield line theory and shell, difference between equilibrium and compatibility torsion, what do you really mean by torsion in a beam. So all these concepts are going to be shared with you, and all your result interpretations, column design. You will end up scheming and detailing the project. So you will learn slab, design, detail, everything, and even some live videos which we have recorded in the class. All these are going to be covered in this course. So basically it will enable you to design a project, a 5 to 10 floor building all your own, from scheming onwards to detailing. So that's the result that we focus on. Only thing is that you need to interact with me to get the benefits. If you just watch the videos and then don't interact with me based on the plans, then there might be a small issue. Otherwise, these are going to help you to be independent. So there are various learning plans that we have provided for your learning. So it starts from 5,000 and ends at 15,000. And 5,000 is a plan where you get 6 months access, and you get doubt clarification by email, and you get one extra project for your practice. So this is good enough for many of you, but if you want more clarification from me and more access time, then you can go for one of these plans, either 8,000 or 10,000 plan. The 15,000 plan is a live class, either in the office, which is suspended now because of pandemic, or this is going to be 100% live on Zoom. But this will be in batches, which will be announced later, but these 3 are available now. So if you are wanting, you can start from 5,000 where you get the same content but 6 months access and email clarification. And in 10,000 plan, you are going to get 3 years access and all my support. You will have Zoom sessions also like this if you really have a doubt. Otherwise, you will get extra clarifications on a daily or 2 days basis. You will get, or you will get an extra video when you have a doubt. I will record and send you a link, something like that. If you have a very severe doubt, you will get a Zoom session like this. Otherwise, we can clarify. So that way, you will have 3 years access, you will have 5 extra projects, and you are going to learn from this. So if any one of you are looking for any of this, those who attended the webinar, I am going to give you an offer, and this is only for those who have attended the webinar and those who are going to tell me very soon. So this 10,000 plan will be made available to you for 8,000, and the 7,500 plan is going to be made available for 6,000. This is only for those who have attended the webinar today and who are going to get back to me very soon. Yeah, so these two plans have offer. This doesn't have an offer because this is a minimum fee that we have kept for any plans. So 6,000 for the 8,000 plan and 8,000 for the 10,000 plan for those who attended the webinar, and those who have not enrolled so far. This is a current offer. It cannot be applied to existing students. This is a new offer, and those who want to learn new and who attended the webinar. Fine, so you can get back to me. So if there are certain points which are missing in this and which you want to say maybe no, if it is within the course, then we can always discuss like stair or water tank, things like that, which I might not have put here, but it's a very simple thing. It's a secondary structure. We can always include that. Yeah. So in case if someone wants to learn building information modeling, we also have a course in Revit structures, which you can explore later. So it's here in the all courses. If you see here, we have a course on Revit structures, which you can look. We also have a course on foundation design, which you can see. But what I spoke about, this is the main course that most of you will need. You can get back to me. And as always, if you have anything stopping you from progressing on your own self-learning, you can ask me doubts. You have to email me. Even if you have not taken a course, I will be able to help you, but not on a immediate urgency basis. I might not be able to get back, and on chat also every time I may not be able to get back. So if you email me, I will try my best, but I cannot commit a time scale to respond. Please understand that. So any questions you can ask me, or if you want to enroll, you can get back to me after the. Any other questions? Anybody? Who is this? Yeah, tell me. Yeah. One second. Which one?
Not that one, the other one. The one that has columns and beams.
Yeah.
Yes, this one. Column B1. You check the way the column
so
B1 is placed.
I understand your question. So what you are saying is this span is less and this span is more, and why didn't I keep this in the other direction? So there could be two reasons which I don't remember. One could be that earthquake point of view. Once I did my seismic analysis, when I completed that, I got the seismic my moment. Say I might have placed it in the other direction first. I'll just copy and I might have tried this first, and then I realized that after seismic analysis, I realized that the other moment is more, so I rotated. That could be one of the keys. Or there might be architecturally some reason, there might be some window or something. Let me just check that. So in this level, there is no problem. I could have rotated in this direction also because the window is far away. But in the upper levels or in the lower level, maybe I have to see that plans I'll have to open. Yeah, here it is there. I think in all the floors, architecturally, it was feasible. So there was no issue with architectural things. So probably it would have been the seismic effects, which made me. No, see the plan. This one, right? Yeah. So see here, I cannot rotate it inside. So here you have an issue. And going to the end was also not feasible because of some regulatory issues, because the setback or something was a concern. So the architect was not okay to have this column at the end. So we had to limit the location here in this particular case. So I cannot rotate it inside. It is coming and clashing with the space. So that was the reason. So maybe the steel would have been slightly lesser if the direction was the other way. Not sure. Yeah, so there are various things like that. So you have to cut a balance between that. So as long as you are not over reinforcing to manifold, then that should be okay. And it's a minor variation. So it doesn't matter. Anybody else? Yeah.
Sir, how to do?
So see, basically when there is no tie, that effective length of the column will increase. Now when your effective length is more, your slenderness calculations also will have to be considering the unsupported or whatever is the effective length. Yeah. So instead of, if your floor height is 3 meters, now it becomes 6 meters, and you have to consider more slenderness moment. That's it. So your effective length estimation becomes more critical. So estimate the right effective length, ensure that you are taking that into consideration in your model. ETABS directly cannot tackle that, because at every story level ETABS breaks your column and take your effective length as 3 meter. So you have to overwrite your
Yes, sir.
parameters. If you know ETABS, instead of 3 meter, or by default ETABS will take the floor height or the story height as your effective length, not effective length, your unsupported length, and then calculate the effective length. That you will have to overwrite and ensure that the floor height is picked by ETABS. So how to do it, I cannot tell you now. All these are covered in the courses. So you have to ensure that that slenderness is captured basically. So that additional slenderness moment will come. You have to design for that. Okay, I think then that's it from me. So let's wind off. It's already 12:15 as well. So thank you for your time. I hope this was helpful.